Uh, Good afternoon, everyone. I once again welcome you all for this training program on decentralized wastewater treatment. Yeah, I hope we have some participants joining from Ethiopia as well. So welcome you all the participants from Ethiopia as well. Uh, During this whole session from the morning, you have been introduced about the issues and challenges about the wastewater treatment in India, especially. We are here in India, we are talking about India. Uh, there are several challenges in India, like most of the plants we have installed capacity, but they are not working. Somewhere there is a problem of electricity. Somewhere we have a problem of skilled manpower. Uh, you have been already introduced about how to overcome these issues. Parallelly, in the previous session, you have been introduced about several technologies for wastewater treatment available in India and their capacity ranging, their cost and everything. During this session, I'll be concentrating on one more technology based on the root zone or the conserved wetland or the phytoremediation based technology. The technology name is Phytorid technology, developed by CSIR NEERI, that is National Environmental Research Institute, Nagpur. Before going to the first slide, I would like to ask some questions with the participants. I hope. I think all the respected participants belong to ULBs, pollution control boards, right? So you must be knowing about the technologies available in the market because you must be installing that. You have some installed STPs in your locations, towns, and villages, right? So can you please tell me what are the different technologies you are working with currently? Yes, please. At least name of the technologies available. You must have installed, right? SBR, fantastic. Next. UASB, WSB, WSB, WSB. Yes, correct. MBBR. Can you please again elaborate with the full form of these technologies? Fantastic. Very good. Again. Sequential batch reactor. Again. From this side, there are a few more technologies available. Yes, sir. Okay.
Tiger biofilter.
Pardon?
Tiger biofilter.
Okay. There are n number of technologies available in the market, and at several places these technologies are installed. Advantages, yes, they are meeting the norm. Can you tell me few disadvantages of these type of technologies? What are the disadvantages of this type of technology? These all technology which you have named comes under the conventional kind of technologies. Correct? So conventional type of STPs have some lacunas or disadvantages. Can you list out them also? Yes, please.
High capex, high opex.
Could be. Yes, high OPEX. Correct.
Larger land area required.
Land area could be one of the disadvantage.
Skilled labor is required for operational.
Fantastic. Yes.
Electricity consumption is very
Yes, to the point. Electricity consumption, yes, again.
and maintenance mostly very.
Correct. What happens is we use these conventional technologies. We installed it. But the problem, the major problem which we face in our region is to maintain it. Yes, we have a lot of plants, big capacity plants, but we are not getting the expected outcome. Most of the plants which are installed are not working. Why? Because there is no electricity available. Even if electricity is available, we don't find a skilled manpower to operate it, plus chemical consumption. So with these aspects, most of the plants are sometimes closed, sometimes unoperational, sometimes they are operational but not meeting the standards because of the operational issues. So what are the possibilities to overcome these issues? Can anyone suggest, please? What could be the possibilities over this? हमें पता हो गया है, like, we know that I deliberately don't want to talk in English because we have a participant for Ethiopia. It is difficult for them to understand Hindi. Okay, so what are the possibilities? What can be done to overcome this kind of challenges? Because this program is actually for this purpose only. You have come across from several states to understand what are the issues, what are the alternate options, what are the capex, how are the design, how we can implement these technologies in our state or the regions, right? This is what the program is meant for. So what do you think, what could be the possibilities to overcome these disadvantages?
Non-conventional methods, like
Non-
on-site sanitation.
Pardon?
On-site sanitation.
Okay. Can you elaborate more? Yes, from this side also. Please try to, at least try. Whatever logical thinking comes in your mind, you can tell. I don't want exact answer, at least logical, because this everything is logical.
Nature-based solution.
Correct? Yes. So what we want is to overcome this kind of issue. We need such technologies which can be installed at lesser space, which can be run with rather unskilled or semi-skilled manpower, which should be energy efficient, should be run at minimum or negligible O&M cost, and should be sustainable. We should not use any chemical consumption, and most important, even after doing so much of exercise, it should meet the permissible limit. That is what is the requirement. We are facing the same problem. Madam also again told the same thing. उनका cost इतना जाता है, operation cost ज़्यादा होता है, right? To overcome this kind of issue, what we need is sustainable technology, which can be a root zone technology or a construction plant based or a phytoremediation based. Construction is easy, operation cost is easy, whereas space required is, let's say, space required is nearly same. But rest thing, if you compare with the technical background as well as life cycle cost, it is much more advantageous. So moving ahead. This is not working. Yeah. So this is the command and control based technologies, conventional technology. As soon as the conventional technology name comes, the first picture comes in the mind is the big STPs with huge size of blowers, motors, pumps, huge energy consumption, so much of skilled manpower with the coat and blazers operating the STPs, right? What we want is, we want to shift this to the eco-based system approach, where everything can be done by the nature-based approach, right? So this is the technology known as Phytorid technology. The brief name is phytoremediation. The class is phytoremediation, which is actually the paradigm shift from command and control based approach to the ecosystem based approach, right? The technology is based on ecological wastewater treatment designed to mimic the cleansing function of the wetland with a smaller footprints. Let me take you to some early stages. You might have seen in the rural location, or recently also you can see there are some specific type of makeshift kind of toilets you might have seen in the rural areas. झाड़ पत्ती से बना के they just cover it, and there is a toilet where they use for daily purpose, and the waste which comes out from that makeshift toilets running through the stream, where you find a typical kind of vegetation, typical kind of plants you might have seen, the cattail, the reeds, some big leaf plant, right? These are some specific plants which grows along that channel of the drain, right? Everybody would have seen. Those are actually the wetland system. These plants are actually made, or by God, you can say, for the cleansing function of the wastewater only. They have a specific functions by which they treat the wastewater. I'll tell you in brief how they treat, but that is how, this is the genesis of the constructed wetland system. We have studied those phenomena. We have done engineering on that. made an engineered structure with proper retention time structure tank, and they did several analysis to treat the wastewater. How many plants are required to treat this kind of waste? How much space will be required? Kitna residence time hona chahiye? So these are the factors which we have studied and finally come up with the design of the cultural wetland. This is the Phytorid technology. Nothing rocket science, a simple technology which is already available from last thousands and millions of years before, just studied and made in the engineering fashion. It has a combination of physical separation and nature available biological component to treat the sewage. Again, we have made several components. As like Sunita ma'am already told you, any STP have a primary, secondary, and tertiary system. That is the unique process. That is the process. How you put your component in the secondary, tertiary, and primary, that depends on your design. Similar way for Phytorid technology, we have a primary, secondary, as well as tertiary system. I'll tell you in detail in the next slide. Also, this type of STP add to the aesthetics of the system. Usually, whenever a name come STP, we have to install an STP. The first thought and first location which we decide for the STP location at the backyard. It should never be at the front. Yes. Whenever anyone says कि हमको STP बनाना है, so he said, yes, there is a space far away from the building at the back side of the building, right? That is a space you can be utilized. This STP actually changed the scenario of those all thinkings. This STP can be installed in your garden along to your periphery of the building. It can be act as a boundary wall of your system or the area. So it adds to the aesthetic as well. And obviously, it meets the current permissible limits laid by NGT. It meets all the parameters. These are the inlet parameters, which are the general parameters for all domestic sewage. And these are the outlet parameters for which we designed the Phytorid-based system. Yeah, moving ahead with the components of this kind of system. This is how the system looks. It has, again, the preliminary treatment system where we install screen and grid chamber to remove all the floating plastic, rubbish material. Then comes with the primary system where we have a settler tank, which is again an RCC tank with an baffle kind of arrangement in the tank. These are the baffles. This is the closed tank. Because what we want here is an anaerobic reaction. The system follows anaerobic as well as aerobic treatment. What is anaerobic? The treatment which done in absence of oxygen or air. Whereas aerobic, where we need oxygen for the treatment process. How I'll tell you. So this is the first part after preliminary treatment, which is the settler tank, where partial treatment happens, almost like 30 to 40% of the pollutant load reduces here anaerobically, followed by the secondary treatment, which is the Phytorid bed. Now, this is the heart of your system. It is again an RCC tank with baffle kind of system filled with different gradient of gravels. The bottom layer with a light color is the big size of your gravels or pebbles, almost like 180 to 200 mm size. Next, intermediate level is around 100 to 120 mm size your gravels. And the top level is filled with the 30 to 40 mm size of your gravels, small gravels. Why? Because to maintain the rate of diffusion. What happens here, how treatment happens, I'll tell you. Here, how the process, once the partial treated allows to flow into the bed, it flows into this kind of pattern, up and down, as well as horizontal. This is known as sinusoidal flow pattern. The advantage of this pattern is each and every drop of your wastewater comes into contact with the gravel surface. What we do here is we add some specific kind of biomedia culture, which actually gets accumulated on the rock surface. This rock actually acts as a host or the catalyst for that bioculture. They form colonies. They cover the whole rock and engage into the treatment of the wastewater. What they actually do is they actually decompose the pollutant coming from the sewage. And since it's an aerobic treatment, it needs oxygen. The bioculture, which actually oxidize the waste material, needs some source of energy. That source of energy comes from the oxygen. Where that oxygen will come from? That oxygen actually comes from the plants which we planted on the gravel surface. This plant has specific culture, which I told you in the previous slide. I will going to tell now. This has a specific characteristic that it actually releases oxygen from the root nodules. This oxygen in turn consumes by the biomedia present in the sewage or what we add in that. By using that oxygen, biomedium itself sustain, and as a food they consume all the organic pollutant present in your wastewater. The first part is complete. Now in wastewater, what else do we have? We have nitrate and phosphate. First is the solid waste. Next is the nitrate and phosphate. Nitrate and phosphate is actually a pollutant for us, but those are nutrient for your plants. Whenever we add pesticides, that contains NPK, nitrate, phosphate, and potassium. That these plants get readily with the sewage. So what this plant does is, first they supply oxygen, which helps biomedia to decompose all the organic pollutant. Plus, they have a capacity to consume all the nitrate and phosphate for their own growth. So this way, the plant itself grows and helps by supplying oxygen to reduce the pollutant load. And along the length of this bed, this is how the pollutant load reduces. So this is the beauty of this plant. In SBR and MBBR, let's say MBBR or SBR, we use blower for aeration. That blowers are completely ignored in this. They are out of the syllabus. That blower work is being done by these plants. One more type of diffusion is occurs is whenever water comes from to the top, it comes into contact with the ambient air. Here, the maximum mass transfer occurs, where oxygen from the ambient air get diffuses and get distributed along the bed, which helps to maintain the DO level in the bed. This is how the treatment goes in the bed. So this is, yes.
There's one hand raised, you can ask a question.
Hello, Sinopia, you can ask a question. Dr. Sinopia?
Hello, yes, can you hear me?
Yeah, we can hear you. Please go ahead.
Yeah. I have one question. So in this, in the picture that you have shown, the settling tank is under the ground, right? So it is underground. It's constructed underground, and so the water is pumped into the Phytorid bed. So can that be on the top, like on the same surface, so that it could run in the gravity flow itself to avoid pumping?
Yes, I was about to come this point in the next slide, but I'll tell you in this slide as well. Yes, whatever you have pointed is the correct. This is just for the representation purpose. Based on the hydraulics, we can modify or we can alter the design. Let's say if you have a sewage coming from, let's say, from the ground level, which can be easily allowed to go to settler tank, this fighter bed can be brought down. What we have to maintain is just the inlet and outlet level. The outlet level of each tank should be at least 100 mm below the inlet point, so that the gravity flow can be maintained. This is deliberately shown in case your sewage at the dedicated spot is at almost 2 meters below. In that case, you need a minimum pumping. Otherwise, you don't require even a single pump. If hydraulics allows the flow to get into gravity flow, so in that case, we don't require any pump. So yes, correct. This bed can again be brought down, and whole flow can be allowed to flow it through the gravity. I hope I have answered the question.
Yes, yes. Thank you.
Yeah. So moving ahead, this is the primary treatment where all the solid separation, partial TSS and BOD reduction is done. Yeah, this is secondary treatment where bio-oxidation of organics is done by bioculture, which is just a one-time addition. We have to add just one time during commissioning. It forms a colony, it forms colony within 24 hours, and next it never required to be add again. This is the last part, which is the tertiary treatment. Again, it's the optional one. Earlier, we were not giving this tertiary treatment as a treatment unit, but with the current norms laid by NGT, this has become mandatory now. The tertiary treatment, what we give is a small dose of chlorine around 5 ppm plus sand filter and a carbon filter based on the water quality outlet after the bed. If we are getting BOD below 10, TSS below 20, we don't recommend to use tertiary treatment also. So this is again optional, which I have mentioned. So this is about the component of the Phytorid system.
So the quality of inlet water and quality of treated water, is it within the
Yes,
NGT norms?
yes, yes.
And what is the overall cycle time of this treatment?
The total cycle is almost 2 days. 2 days of the retention time is given. Design is for 2 days. Almost 1.5 day with 1 day, or you can say with the Phytorid bed, and 1 day with the settler time.
Pathogen levels are only taken care of the Phytorid that also reduces.
Partially with the settler tank anaerobically, and rest with the bed. Almost 30 to 40% treatment is being done in the settler tank. Rest 85 to 95% is being done in the Phytorid bed.
Is there an option even after Phytorid bed if you want to reduce the pathogens rather than going for the chlorination?
Yes,
We go for the this thing, vertex filter हमने लगाया तो vertex treatment unit लगाया या फिर we can go for this what type of
yes, anything can be installed. Yes, yes, yes. You can install tertiary treatment. There are n number of tertiary treatment like RO, UV, then you can say chlorine hai, then PSF hai. Nature based also. Yes. As long as the desired parameters are involved, you can add n number of tertiary treatment units. If you want potable water, that is also possible, but we have to go through the 7 steps of the treatment to get the potable water, which you can drink also.
And the last question.
Yeah.
I think filter media is something which is the patented one.
Not the filter media. The overall design is the patented part. The bed itself is the patent part, the residence time settler and the bed combination. That is the patented part.
Not just a simple.
It's a simple media, a gravel media.
But structure is not a simple structure actually.
It's a simple civil structure, but for capacity to capacity, how the residence time will vary and how the design should be, that is the patent. Media in the sense I am talking about the gravel media field, not the biomedia. Biomedia is also a patented one. Yes, yes, bioculture media is the patented one. Bioculture media as well as the plant which we use are the acclimatized plants. If you just purchase plant from nursery and install, there is a high probability that it may die within a month. What we do is we acclimatize those plants into the septic conditions. We made it favorable to that condition, then we plant so that the probability of the plant to die is very less. Shall I move? Any more questions? Yeah. Yeah. This was the design of the bed system. Now coming to the salient features of the STP. It is most of the hydraulic design is on gravity, which ma'am has already cleared answer. I was about to answer that in this part, where hydraulics are completely based on the inlet level of the sewage. Let's say you have a town where all the sewage is getting collected and discharged at the steepest point. What is that steepest point with the GL level? That is what we want. Based on that, the design is made. If you have a depth where the sewage is coming at below 2 meters, obviously you have to lift. This plant can go down, but just by increasing the freeboard, your economics gets increased, your civil cost get increased. Instead of increasing the civil cost, you can install a small 1 HP, 2 HP pump for smaller capacity. Again, the pump capacity is based on the capacity to capacity, what is the inflow. So to answer that, based on the hydraulic, the design is made, how much deep it can be constructed. Yes. The second feature is minimum electricity power requirement as compared to the conventional STP. Yes. As compared with the conventional STP, it does not require heavy instruments, no blowers, no heavy pumps, no big panel, no sensors. So that way we can reduce the electric consumption cost, which is a major requirement nowadays. Easy to maintain. We don't require any skilled manpower. A gardener kind of person can maintain this plant. The only maintenance in this plant which we have experienced is whatever plants we plant in the bed, since they get huge nutrient, so they have very good affinity to grow. Within a 2 month or 3 month, you can actually find a full garden developed. What we need, a regular harvesting of this plant, so that the uptake capacity of the plant should maintain. It should uptake the nutrient continuously. Once they get saturated, they may reduce the capacity to uptake the nutrients. So we need to harvest this plant regularly. Let's say after quarterly we need to harvest it. We have to maintain the particular, so that the capacity of the plant to uptake nutrient can maintain, and the dissolution of oxygen should be maintained. That's why the major requirement is the gardener kind of person who can harvest and maintain this plant. That is the only maintenance required. Yeah. So we use these plants which sustain at -5 as well as 45 or 50 degrees Celsius. I have a plants installed in Himachal Pradesh, Mandi district also, where temperature is -3, -5. I have plants. Yes. If you go with the thumb rule, for let's say 1000 KLD plant, the thumb rule space required is around 1200 square meters, the carpet area. If you want to build a 1 MLD plant, you need 1200 square meter का space, carpet area. That is the space required for Phytorid. We have done several advancement in the technology also, where now we have brought down the space required from 1.2 to 0.7, 0.8, similar to the MBBR or SBR kind of space. Because this was a challenge with us also. Wherever we have installed or we have proposed, they have brought with the comparative technologies. Yes, ये boss इसमें तो space कम लग रहा है, आपके इसमें थोड़ा space ज़्यादा लग रहा है. What can be done? So considering this fact, we have done central advancement in the technologies. Now the space required for our STP is around 700 to 800 square meter for 1 MLD plant capacity. Yes. Next advantage is no bad odor, because settler tank, treated water tank, all are covered tank. No chance of the odor coming out. The only bed which is open to air is the Phytorid bed. This is the bed. In that also, what we are maintaining is the inflow to the STP is almost 100 to 200 mm below the gravel surface. Maintaining that, never ever the water comes to the top level of the gravels. Every time the water flows subsurface. So there are no chances of odor, no chances of mosquito, no chances of nuisance. It looks like a garden. You can also walk on the plant. You might have seen the same in the premises also. You can see there is no water accumulated on the top. It is always dry. Most of the plants which we install, let's say in Pune, we have installed in the Siemens company in the garden premises. Laborers and the operators who work there during lunchtime, they eat their tiffin sitting on the plant because they don't know this is STP. They don't feel anything. There is no smell, no mosquito. They feel like we are sitting in the garden and we are eating the food. They don't know below 100 mm there is a sewage flowing and getting treated. So that is the beauty. No pumps, no smell, no sound, nothing. Yeah. Next is the scalable. It can be considered from 10 KLD to 50 MLD also in batches. As to acidic, I've already introduced about that. Low life cycle cost. When we compare with the conventional STP, I'll also tell you about the cost also. Although this cost session will be there in the day 3, which will be done by the experts. But for this kind of STP, capex is on a bit higher side if you compare with the SBR and MBR. Why? I'll tell you. These are the passive system. Everything is done by natural treatment, where the kinetic or the rate of the treatment is on the lower side. To meet the permissibility, it requires a time for treatment. Since the time is involved, the space is involved. That's why the capex is high. At some point larger than the MBBR and SBR. But when you compare with the life cycle cost, let's say 5 years to 10 years, with the maintenance also, you are actually much more benefited than the SBR and MBR. You can actually get ROI in next 3 years to 4 years. So that is the beauty. Application wise, this can be installed in residential colonies, hostels, offices, all rural kind of areas, urban region. You can also install nearby Nala where interception diversion treatment can be done, which is in currently demand by ULBs. They want interception diversion treatment to be done. There and there itself. There also these kind of plants are installed. For lake rejuvenation, river conservation, also these plants can be installed. Resort, hotels, restaurant, all kind of industries or the sectors, wherever there is a wastewater, these kind of plants can be installed and the water can be treated. The beauty is we can install right from 5 KLD till 50 MLD easily. So decentralized way or the centralized way, both way it can be installed and can be run. Moving towards the technology recognition. Whenever you have a technology, you should also have a reckon whether it has been analyzed, whether it can be checked or approved. So this technology also have a recognition by Raghunath Mashelkar Committee for innovative technology in field of water and sanitation. Next, it also being endorsed by Ministry of Drinking Water and Sanitation for the technology based on no power requirement for maximum recycle and reuse of wastewater. This also been recognized by MODWS for innovative technologies. Yes, it has already adopted by Maharashtra government, where Maharashtra Jal Pradhikaran has installed n number of plants in Maharashtra. Also, now it has been adopted by UP, Bihar, Orissa, Jharkhand, MP, Chhattisgarh, AP, and Telangana. In MP, currently there are almost 100+ plants are live tenders for this kind of STPs. They want coastal wetland to be installed in the rural areas. So these are the good examples. You being the ULB officers, where are the case studies? So these are the case studies where these plants are already existing, being tendered, installed, under operation maintenance. Taking these examples, you can also propose these technologies for your regions. Yeah, I was talking about the innovations. Space requirement, the conventional kind of, let's say this is the space requirement for Phytorid STP. ESTPL with this experience and innovation has worked a lot on their primary and secondary treatment and brought down the space required up to 30% less, which I have told you 1.2 was the factor for 1 MLD, 1 is to 1.2. Now it has been down to 1 is to 0.8, 0.7. That is the factor we have worked out. Since the space is reduced, the cost is also reduced. Earlier, the cost required, let's say for this type, now with this innovation, the cost has been reduced to 15% down. So this is much more sustainable, much more feasible, more economically feasible, and rest all beauties are already told to you. We are now into the 11th year promoting these technologies with strong technical background, 10 years of the efforts putting in this plant. Almost 10 states may we have a presence, we have installed, and we are also the technology provider of one of the biggest plant in India. If I am not wrong and my knowledge goes, this could be the biggest plant in the world. 20 MLD size STP on conserved wetland. Never ever I have seen, as far as my knowledge goes. If you have, you can always tell, but I have not seen 20 MLD or bigger size plant based on the conserved wetland based STP. We are the consultant for that plant, and that plant, I'm happy to share this news, that has been commissioned just 10 days before in Alwar town only. In Alwar, there is a STP based on constructed wetland technology with a capacity 20 MLD size. I'll show you the images coming in the next part. So moving to the case studies, till now we have talked about the technology, their components, what are the advantages, the recognitions, where it can be used, who are the potential clients or the stakeholders for the technology. Now, these are the case studies which we have experienced, where these plants are actually installed community-wise. I'll tell you. This one case study is for the schools. We can install for the government schools or the private schools also. You can promote in your region. This is one plant installed in Nagpur for Munle Public School, running from last 2 years, 100 KLD capacity. This is how the plant looks like. This one more plant for the school, again in Nagpur Achiever School. They were very passionate client. They want, their requirement was, since there are kids who are studying in the school, there should not be any smell, no odor, no harsh chemicals or the instruments running in the school premises. That's why they have opted this kind of technology. This green garden they have actually installed along to the boundary wall. This is not a garden. This is your Phytorid STP. And the treated water which they are getting from the system, they are using for that toilet flushing purpose. Complete treated water using for the toilet flushing. That's why they are reusing the water and they are reducing the consumption of the tanker water. And henceforth reducing the cost. This is one plant we have installed for railways. Indian Railways are also very passionate regarding these kind of things because they have space. They said, yes, we have space. We want, this is the last priority item for us. We are busy in running the trains. We don't want to operate STP. We want such kind of STP which can be run by their own. So tell us such kind of sustainable technology which can run by gravity without a minimum, without extra maintenance cost, without skilled manpower, because we cannot see them, we cannot check them. So we have proposed this technology. This is the plant installed in almost like 4 years before. To 2020 mein installed hua hai, and it is running fantastically. And till date, this again is the old figure. At that time, we have treated almost 40 crore plus liters of the water. And this water is again getting reused for the horticultural purpose as well as for the toilet flushing in their hostels. They have a ZRT as a Zonal Railway Training Institute where the officers are getting trained. They are reusing the treated water for the toilet flushing purpose for the ZRT Institute. One more plant we have installed for railways in the Nashik station. You can go anytime and visit this plant. Nashik station pe they have platform where they have installed and the treated water being used for the platform washing purposes. They have reduced the consumption of the potable water and they are now using the recycled water from the STP for their platform washing. One more good case study. Recently, we have commissioned a plant is, yeah.
This platform is right, but this is the way.
Yeah, this was not the platform. Platform is just beside this. This was the open space available. There was a rubbish land. We have converted that land into the STP. So what they are doing is whatever waste coming from the toilet and the nearby region from the railway premises going to the drain, we have tapped the drain, we have constructed a weir, and total water is being diverted to the STP. And this water is getting treated, stored in the overhead tank, and whenever they require, they reuse the water for platform washing as well as coach mein jo pani bhara jata hai tank mein, which we use for toilet flushing in the railways. That also they are filling with this water at a Nashik station.
Structure, this elevated structure.
This one, this is the settler tank. This is the settler tank and this is the bed. I told you the hydraulics. Water comes to this bed by pumping from the nala, and from this point till the last point, everything is by gravity. The total complete treatment is energy free. No energy required for the treatment purpose. This whole plant. And this is how the plant looks. Nashik station actually got the 5-star rating just because of this plant. In their environment, they have an environment department. That environment department got a 5-star rating for Nashik station after the installation and commissioning of this plant. One more project we have, after giving so much of the success story, they have given one more plant. This has been recently commissioned at the Vadibandha station, Mumbai. Here, what they are going to do is whatever water collected from the washing of the locomotive, whenever they drop you, they take their vehicle for the service station where they clean the vehicle. Whatever wastewater or the toilet waste coming from after washing, they collect that water. They are going to treat that water with this STP, and that water again going to reuse for the locomotive washing purpose. So this is one more plant with the railways. This plant is again installed in Nagpur for hospital, where we have made a unique design combining ETP as well as STP. ETP has been initially designed for the advanced oxidation treatment, where we give ozonation to treat complex molecule of the pathogens and antibiotics, where they get broken, and the further treatment has been done using the Phytorid bed plant. This is 1 mld capacity, and they are using this water again for the toilet flushing, as well as they have a lake nearby. They have actually an amphitheater. with the adjoining lake. They are discharging the water into lake where they do boating and all and maintains the aesthetic of the hospital. Yeah, I was talking about 20 MLD. This is one of the biggest plant in the world based on the conserved wetland capacity technology in Alwar itself. This has been installed by the Minister Environment and Forest just 10 days before. Plantation is yet to done. We have just allowed the water to come into bed, and yesterday itself we have got the water at the outlet. So now the plantation is going to done, and mostly by 1 month it completely ready for treatment 24/7. So this is one of the biggest plant live. We can proudly say yes, in India we are using this technology for sewage treatment. Conserved wetland is very much accepted and available. This is the biggest plant.
Single module or it have, multiple modules?
It has two modules actually, one bed and second bed.
There are 2 beds.
Yes, the baffle you can see the yellow color. These are the bottom open baffle. In between there are top open baffle as well. Water comes from this point, flows along the bed in sinusoidal pattern, and this is the outlet. This is the tank where the water gets stored, and further tertiary treatment is done. At this side, as I mentioned, there is a facultative pond. The overflow from the facultative pond get allowed to come into the bed. It acts as a polishing unit. Here, actually, there is existing STP. I told you that this plant can also be act as a polishing unit. This location already had an STP in the form of facultative pond, but that pond was not able to meet the permissible limit, the current permissible limit, which is BOD below 10, COD below 50. The output which we are getting is around 100 to 120 BOD. So with that output, Rutshiko has approached NIRI, and NIRI has suggested to install this technology. It has been installed, and now we are very much sure the outlet of the plant will. Pardon? No. This sara gravel, sir. This all is gravel. Again, this is filled with the 3 gradient, as I have shown in the initial slide. It has a depth of around 2.5 meter. The bottom is filled with the large size pebbles, intermediate size with the intermediate size gravels, and this is the top level, around 30 to 40 mm size of the gravels. It is around 2.5 meter deep. So water flows, goes down, comes up, again goes down, again comes up along the bed, and that's how the treatment is done. I'll tell you the again thumb rule for this. Let's say you have a 2.5 meter depth. The bottom layer is 25% of the total depth. Intermediate layer is around 50% of your total depth. And again, the top layer is 25% of your total depth. So 25, 50, and 25. You will never forget this. Plantation is this is just commissioned last 10 days before. It is in process, and it is so big a Olympic size STP. It will take some time, at least a month, to install and commission completely. Yeah. No. Again, in that also we have designed it much more economical way. What we have suggested here, instead of doing so big a RCC structure, we can make an embankment kind of structure with the stone masonry, and this complete bed is laid with the geotextile membrane. The complete structure is laid with the geotextile membrane. On the top of it, we have at the bottom we have given cushioning, and on the banks the stone masonry work is done. So we have maintained that water will never get leaked. What we need is this tank should be a leak-proof structure, so that the water level should not get reduced. Yes, please.
How can we deal with the addition of rainwater?
If rain comes from the top, no issue. From this side, no issue, because it is a diluted sewage, but it should not come from this side.
Most of the studies which we have seen,
Yes.
those are of arid regions, like Gosawal, Nagpur, and Jaisalmer.
Yeah.
These are the regions which experiences limited rain.
Okay.
So how can we implement this technology with heavy rainfall?
Only thing what we have to maintain.
The addition of surface water.
No, what we have to maintain during rain also. Whenever we do design, we always ask one parameter to confirm at the site. What is the high flood line level? What we want is the bed structure, the top level of this wall of this tank should always be at least 0.5 meter above the high floodline level, so that water should not get enter from the side walls. No matter, it can come from the inlet because it is a diluted sewage. If diluted sewage comes, there is no issue with the plant. If it comes from the side walls, it have chances to bring soil with it. It has the chances to bring all the rubbish material which can block the pores of the bed. That is what we got not on. That is we actually try to avoid. It will spoil the functionability of the STP. If it comes from the inlet with primary treatment, that is fantastic. That is possible. It can be done. What we avoid is water should not carry the waste from the sideways. It should not block the pores of the bed. That's all we want. For that, whenever we design, we ask for one parameter. What is the high floodline level at your dedicated or the decided lab? If that is available, we design it accordingly. So we avoid that chances of pore blocking. Doesn't require because we don't allow solid to come into this bed. All the solid are getting handled in the settler tank. We have a baffle kind of arrangement tank that is made just because of that only. In the first and second chamber, solid get arrested, and after that, only liquid with organic solid which can be decomposed are carried to the bed. And that settler tank need to be desludged at least one in a year. And that too, with the addition of bacteria, that sludge can again be decomposed. We have a plant installed which have never been cleaned from last 5 years also. But while giving the design, we recommend to clean or to desludge it at least once in a year. And that desludging is very simple. Nowadays, we have a vehicles, desludging vehicles. They bring a tank, they have a machine, they just suck the sludge and take the all fecal sludge away. A very easy part. Yeah. Yes, please come. No, again, this is the polishing unit. Here, the BOD which we are getting at the inlet is around 80 to 100, not 250 to 300, which is the general characteristics of the sewage for domestic sewage. They already have a STP, facultative pond. It is not meeting the norms. What they want is to meet the norms with the current stringent standard. So this plant has been designed considering the inlet BOD is coming around 80 to 100. So in that sense, we does not require that factor. That is based on the pollutant load which is coming to the STP. Here the pollution load is less than 40%, what we designed for. So accordingly, the space requirement has been reduced.
बेसिकली एसटीपी पे लगा हुआ है, इसीलिए ये ओवरऑल पूरी नहीं है। एसटीपी के बाद जो चीज पानी आ रहा है,
yes, settling purpose is already getting corrected at the facultative pond. We are not allowing any solid, so that partial treatment is gone. Primary treatment is gone. Only the secondary treatment as a Phytorid bed we have installed it. That's why the space requirement is not as per the factor which I have told. Yeah, point is correctly addressed actually. You have put up the correct point. So moving ahead, this is all about the Phytorid STP, this design, its cost, and the case studies. I hope you have got a brief idea about the Phytorid technology now. Next, we will move on to the in situ drain treatment technologies. This kind of technologies, phytoremediation, say, or you can say conservative land, can also be used for in situ drain treatment. What is in situ drain treatment? Yes, can anyone? I know the last session is a bit hard to digest, but still, just 15 minutes more. What is in situ treatment? Yes, please. Correct. Where the treatment can be done in the drain itself. Currently, what has happened is in recent year, there is one more notification came. All the STPs installed in India should meet the NGT current norms. Should be below 10. Earlier, the STPs were designed for 50 BOD, 250 BOD, and 30 BOD, right? Gradually, the norms has come down. The very initial days, the BOD level allow permission was 150. The plants were designed for 150 also. What to do with that? Suddenly, government is saying that we have to bring down the standard to 10 BOD. You have to do it. They have raised a mandate. But what about the funds? What about the time? What about the technologies? This is not very easy task for ULBs or the bigger urban areas. So with that, they have also suggested one alternate technologies. Why don't we do one thing? Instead of putting all load to the STP or the water body or the river body, why can't you reduce the pollution load in the drain which is carrying the sewage? So in situ treatment has got attention in last couple of years before, where government has now taken initiatives to treat their sewage flowing through the larger drains there and there itself. So this is one of the drain in Delhi, which is known as Pushpa Vihar. While doing such kind of drain treatment, first thing what we have to do is we have to categorize the drain. Similar kind of technology cannot be installed in the all kind of drain categories because every drain has different width. So in that case, what we can do is we can categorize the drain. Let's say 1, 2, 3, 4. These are type of drain which are being differentiated based on the width. Obviously, if the width is low, you cannot install everything in the same width. We have to allow water to flow easily also, and parallelly we have to treat the waste also. Considering these factors, these categories of the drain has been decided. So let's say type 4, where the drain width is less than 1 meter. And accordingly, let's say type 1, where the drain is having the width of 9 meter, where we have the larger scope to install the things. For less than 1 meter, we can only propose this treatment scheme, let's say primary, where only screening can be installed. Whereas for the larger drain, primary plus secondary plus tertiary can be installed, where screening can be done, silt trap can be done, some filters can be installed to do secondary treatment, as well as the floating phytoremediation technique which we have installed in the several drains can be installed. So this way, before doing the in situ treatment, we have to categorize the drain, in which category drain falls, and based on the category, what are the appropriate treatment schemes to be given to treat the sewage and to reduce the pollution load. So that currently, till we get the new plant installed to meet the stringent norms, or the installed plant can be revamped to meet the desired standard, this can be your oxygen. Using this technique, your pollution load can still be reduced, your river body load can still be reduced. So these are the techniques. I'm going to Gabion filter. I'll show you. It's a stones packed in a mesh, a wall of a stone. That is the Gabion wall, which we prepare. Why we need is because it's a porous membrane. It acts as a porous membrane. If we install it in a zigzag pattern along the length, water will again form a sinusoidal patterns and also flow through the pores of the Gabion wall, in which we add some particular biomedia by which the filtration can be done. Similarly, what we're doing in the Phytorid bed, we are adding gravels. In that, we are adding bioculture media. Here also, we add bioculture media where it comes to the contact with the water, getting reacted and decompose the organic water and reduce the pollution load. So these are the steps. Let's say screening. This kind of screen can be installed in the drain where the rubbish or the floating material can be arrested. This is the silt trap. After the screen, we can make a weir kind of arrangement so that the sludge and the silt, which is getting washed away with the water, can be arrested and can be removed. So the pollution load again can be reduced. Third, this is the biological action, which is the floating raft. Again, this is the same plants. There in Phytorid bed, we have planted this kind of plants on the gravel. Here, using this floating polyurethane foam sheets or plastic sheets or coir, any material can be used on which the plants can be planted and allow that plant to float into the nala, so that the root will get in contact with the water, where oxygen can be diffused in the water and further treatment can be done. Similar way as I have mentioned in my previous slides. This is one of the layout I want to show we have prepared for the Pushpa Vihar drain in Delhi. We have suggested, this is almost like a 1.8 kilometer drain where the wastewater was going to the major drain, which is Najafgarh drain, and meeting to the Yamuna, which was a big news couple of years before. So this is one of the major drain where they want to reduce the pollution load. We have suggested initial preliminary treatment by giving screens. Then with the Gabion filters where water flows to the cellular pattern, here we add bioculture media so that biological treatment can happen. And followed by that, this is the floating phytoremediation area where floating bed were installed and treatment is done by biological action, as we have mentioned.
Here the main difference in this technology is the flow actually the vertical flow.
Yeah.
Here the flow is horizontal.
Here we cannot maintain. What we want to do is basically using the baffles. We want to increase the residence time. We want water to stay in that region for more time. Doesn't matter if you are allowing to flow to top to bottom or you are allowing it to flow from the zigzag pattern. What we want is the water should come in maximum contact with the gravel surface and the residence time should be maximum with the limited space so that the maximum treatment happen with the same space. So that's what the concept is. And this is how the drain now looks like. This is the bed which we have prepared, floating bed. And earlier, I don't have the image right now. Earlier, this drain was like you cannot even keep your nose open.
Sorry.
This
This is a natural drainage or artificial drainage? Hello?
I think somebody.
So that's natural. That's natural.
This
Okay.
is natural drainage or
Yes,
artificial drainage?
This is
Hello,
a natural
everyone.
drainage.
Hello.
Hello.
So,
Yes.
hello.
Jyoti ji,
Yes. And
tell them, can I address this question just after the
Yeah. So, I request you all to put your questions in the chat box so that we can take up your questions and answer all the questions at the end of the session.
okay, thank you.
Please.
So this is how the drain currently looks like. We have installed the system and the treatment quality of the water which we are getting outlet BOD is around 20 to 30. This obviously cannot meet the NGT norms because this is the flowing water continuously. We are not arresting it. You don't have a control with the flow also. Sometimes it is at a peak, sometimes it is at a less. But what we are doing is we are actually reducing the pollution load. Right from 200 BOD, it is coming to 20 to 30, which is a very good scenario, which is reducing the pollution load of Yamuna at least certain pollution load we are trying to reduce with this concept. So with this example, now Delhi Municipal Corporation have floated several proposals for such kind of treatment system. Not only Delhi Municipal Corporation, rather many locations in India, ULBs, where they have this kind of major drains, which is discharging their wastewater to the nearby river bodies. They want such kind of quick remedies by which the treatment can be done at least till they get a larger capacity STP installed. This is not the ultimate solution, but can be a medicine till your disease get cured completely. So this is the medicine which we can give to your location also if you have similar kind of problems. So this is cost effective. Cost, if somebody asks me what is the cost of this, let's say if the flow is around 1 mld, the hardly cost for the treatment is 10 to 15 lakh rupees. Whereas for STP, if you go with the conservate land, it is almost like 2.5 to 2.8 CR. Capex cost is 10 to 15 lakhs. Because what we are not doing is the construction part. We are not doing any construction. What we are doing is just a treatment. Dedicated treatment site development cost requires big capital cost. Here you have a space, you have already drain flowing. What we have done is a small dredging desilting part, a small weir kind of structure, and a floating raft as well as biomedium. That's all we have done. No civil structure, major civil structure is involved. That's why the cost has been drastically reduced to 10 to 15 lakh rupees per ML. That is the capital cost required. So this is how the alternately in situ treatment can also be done using the constructed wetland type of technologies. Yeah, this is all I have about the Phytorid STP as well as in situ drain treatment. These are some selected clients with whom which we are working and given our STPs. Yeah, thank you. Now question can come. As many questions you have, please.
Yeah, so
First of all, we take the question from our Ethiopian participants, so that probably some of the answers they can also find from there.
the first question is from Dr. Senafia, that sinusoidal movement of wastewater horizontally or vertically?
Yeah. The sinusoidal flow pattern in the Phytorid system is both horizontal as well as vertical. With the baffle kind of arrangement, water moves from bottom to top, then to something to along the length of the bed, then again comes down and again along the length of the bed and again moves up. This way, it is a combination of horizontal as well as vertical flow.
So the second question is from Inetu from Ethiopia. Is what is nutrient removal efficiency of the gravel bed?
Okay, nutrient efficiency. Let's say if we have a nitrate in the range of 10 to 12 mg per liter, this plant has the capacity to bring down to 0.5 to 0.6 mg per liter. Also, we have found this efficient almost 95% removal rate with the bed, because plant has fantastic efficiency capacity to uptake the nutrients. That's why the nitrate and fecal coliform also get reduced drastically.
We have to use water quality culture. We really need to grab all the
Not really. Not really.
But at some extent, no.
For if let's say if we are using this plant for agriculture purpose, what we need is a nutrient also. In that way, even the plant gives some nutrient also, that is okay for the agri purpose. Otherwise, also if it is below 1, 2, that is also useful for the agriculture purpose. What we want is to meet the NGT standard. Preferentially, NGT standard first. So our plant is designed to meet the nutrient level almost with the removal rate of 95%.
Okay. So next question is from Dr. Senafia.
Yeah.
Is a dairy and food produces more sludge?
Yeah.
How will that be clear?
Yes, for such kind of industries, what we need is the settler tank to be designed very specifically based on the TSS and the TDS level at the inlet. Whenever we design this kind of STP, primarily what we ask with the inlet parameters of the wastewater which is generated from your source. Based on the parameters we design, let's say TSS is much more higher. What we suggest is to give settler tank with a higher retention time with more baffles, so that a maximum amount of your solid waste get trapped into the baffle surface. Plus, sometimes we also give a dedicated tank at the inlet. First, water should go and store into the intake well. Then the upper part of the water should be allowed to flow into the treatment system. That is based on patient to patient, we give the medicines. Whatever the disease which your patient is having, based on that, we have a medicines or the design alteration can be done.
the media quality.
Yeah. Exactly. The media also can be used based, everything is based on the space available, the exact land available. We don't require exactly rectangular land. Let's say you have a zigzag land. That is also okay with us. We will prepare the land in the zigzag plant in the zigzag pattern. If we have a L-shaped land, that is also okay. So everything is based on the space how you have available. Next, the inlet water quality. Currently, what is the inlet water quality at the source? Based on that interval of inlet water quality, we design the equipments or the treatment tanks.
Okay, so next Inetu is asking what is the material type for the top layer of for the contaminants?
Yes, these are usually the readily available gravels, a basalt kind of gravels. You might have seen the railway track has some specific kind of black gravels. That kind of gravel which we need. The characteristics before adding the media into the bed, which we have to taken care is, it should not be brittle. It should remain intact. What happens if it becomes brittle? gradually with the flow of water, it will erode. It will erode, form soil, and eventually it block the pores, which may affect the efficiency of the plant, may not get exact treated water quality. So considering that, we have to select the media to be filled in the bed.
What type of media you prefer, like round shaped or?
No, in fact, we recommend irregular shape.
Okay.
If we have a regular round shape, the disadvantage is it is very difficult for that media, bioculture media, to form a colony. It has high probability to get washed away. If we have an irregular shape with high pores, they may form a colony, that too very intact colony, which will never get washed away with the flow. So irregular shape, whatever the space shape could be, that is recommended.
Okay. So the next question is, how did you fix the HFL? Is it from local information or from extreme flood analysis of a specified return period?
Actually, whatever data for HFL we take is every time based on the secondary data which that concern authority provides us. We never do any HFL analysis. We ask to the authority, you tell us what is the high floodline level, because that can be told by them only. They are living there, they know the data. We are going for the first time, whatever HFL data provided by our client or the stakeholders as a second data, based on that we design our STP. But there are several techniques to analyze the HFL. Let's say nowadays there is urban flood modeling. By this technique, you can estimate what is the HFL level. There are several mathematical modeling tools like HECRAS and GIS mapping, by which you can actually estimate what is the HFL level, what is the flood, when it has come, what are the levels, highest level, that everything can be done. That can be computed, rather, telling that can be computed. That is altogether a different scope.
So the next question is from Mr. Nuruddin Mohammed. Does the gravel require backwashing?
We designed the STP considering that no solid is getting allowed to the bed. All the solids we try to arrest in the settler tank itself. If considering that there is no requirement of the washing of your gravel bed. Sometimes where we have installed the plants and not being maintained by us and maintained by the client for, let's say, 10 years older plant, they have faced sometimes this issue. This is correctly pointed out. I want to elaborate on that. This has been observed. Some initial bed are blocked. They called, sir, ये तो block हो गया, इसका क्या करें? This is blocked now. Water is getting flooded. We went to the site. We asked few questions. This problem majorly arises when you don't follow the operational protocol. Let's say you have a plant capacity of 100 KLD, but you are allowing discharge to 150 KLD or 200 KLD. That means if you run the plant beyond the design capacity, the initial tank, which is settler tank, is not getting operated with the design capacity. In that cases, since everything is based on the physics, the terminal settling velocity of the particles and all, if that parameters are not getting met with respect to design, there are chances, I'm sure there are chances, solids may also get carried away with the wastewater to the bed and can block the pores. The point which we have to take care is, we should run the plant with the design capacity. We have to follow the design protocol. We have to follow the operation maintenance protocol. If you follow that, I'm sure this problem will never arise. Even if that problem arises, we have a solution. What we do is we give perforated pipe arrangement in each phytorid bed. There are pipes which we give. With that pipe, whenever such kind of situation occurs, what we do is we actually do a water jet method. From that perforated pipe, we allow water to flow with the pressurized system. It has so much pressure that with that pores, with that perforated pipe, water actually with the force flows through the pores which are blocked and clear the pores. And in turn, the organic solid gets settled in the bottom, which can be further get decomposed by adding certain bacteria, which completely decompose it, and that way the pores can be again rejuvenated, and again the same with that same efficiency plant can run.
The
But
next question.
most important and the foremost thing is you should operate the plant with the design protocol and the design capacity. If you do that, this situation never comes.
Okay, thank you.
What about the plastic? Which comes in?
Plastic, we actually remove in the initial part on the prelim treatment.
That is the polythene that comes in.
We installed two screens. One is core screen as well as fine screen. So whatever size which are bigger than 10 mm size get arrested in the core screen, and the particle size which are less than 5 mm get arrested into the finer screen.
And some other particles also which are non-biodegradable. So what about that?
If they are floating particles, they get arrested into the settler tank. We have a baffle. First baffle is the bottom, open from bottom. Water comes in, gradually the level rises. So whatever floating solids are there, they get arrested with the baffle only. They never comes to the last stream. We have made 3-4 checkpoints for those kind of plastic material and the material which should not be carried away to the bed. Everything get arrested, almost 99% get arrested into the settler tank as well as the initial preliminary treatment systems.
It has to be cleaned up every day.
Screen cleaning should be done regularly based on the solids carrying capacity of the wastewater. If you have,
Now we can take another 5 minutes to conclude the
Yeah.
discussion because we have.
I'm here for, I'm staying here. If you have more questions, we can meet up in the dinner also. We can
So
have a
just,
chit chat.
Two more questions from Ethiopian participants. One question is from Mr. Noreddin is in the in situ treatment, continuous flow doesn't affect the biological actions which you
Yes.
have mentioned.
In situ treatment, the question which you have pointed out is correct. In our design, what we do is, although it is a continuous flow, but you must have observed, we have given weirs at certain points. So although it is a continuous flow, it's an in situ treatment in the drain itself, but in our design, which we give is a retention wall, where water stays in each compartment for specific time. So although it looks continuous, but we are doing is in a similar way as the STP does. We have a compartment and a weir kind of arrangement where water is stored for a certain period and get treated. So biological action doesn't affect by giving the weir kind of retention system.
So last question is what type of plants could be used? The layer depth of each gravel layer required has any standard or not? If the filter media or void space clogged through time, how can we maintain it?
Yeah, there are several kind of hydrophytes basically are used, which does not require soil. They can grow in water itself. I can name a few like Canna indica is one of the species. Next is the reed. Next is the cattail. Next is the Colocia. Another one is the umbrella palm. So there are several kind of hydrophytes can be used again based on the inlet water quality, because each species has their specific uptake capacity. If you give me the inlet water quality, I can design your plant based on the inlet water quality, what are the plants and the species can be used.
Yes, someone is asking about the design parameters. How you arrive at the design parameters and all.
Okay, so that itself is a big chapter that I have to stand here for the whole day.
Okay, that we can share with you separately if he shares with us.
I'll just give a brief
Yeah.
note on that.
Yeah.
Yes, the question is genuine and should be answered. I could not leave that question. Actually, to be very frank, it requires sufficient time to explain the design of the STP. But in short, I'll tell you, majorly two units are the heart of the system. One is the settler tank and next is the Phytorid bed. If you have a domestic sewage with the specific characteristics, like say BOD 200 to 300, COD 350 to 400, if you have that characteristics, I'll give you thumb rule. Your settler tank design should be of the 24 hours. it should have a retention time of 1 day, whereas your Phytorid bed filled with gravel should have a retention time of 18 to 22 hours. That should be the retention time. And based on this time, you can actually calculate what could be the length, what could be depth, what could be the height. And again, one more point to notice, the depth of the bed should not go beyond 2 meters. And also the length of the bed should not go beyond 25 meters. I recommend not to go beyond 25 meters, because if it goes beyond 25 meters, it follows actually Darcy's equation. In Darcy's equation, it finds more affinity to come up rather than go front. लेंथ बहुत बड़ा हो जाता है ना, उसको ज्यादा इजी हो जाता है ऊपर आना से. वो क्यों आता है, that explains very well in the Darcy's equation. I can explain that right away, but still it requires time. But to follow the Darcy's equation, what we have found that 25 मीटर तक अगर लेंथ रहा ना, आपके प्लांट को कोई प्रॉब्लम नहीं है. अगर आपको 25 मीटर ज्यादा लग रही है, you can make a 2 bed. You can make parallel beds. 25 meter के 2 beds, that is an easy job. Rather than making it to 100 meter length. You can also visualize how the plant will look of 100 meter wall bed. This is not possible. So that way it can be designed. So these are some key fundamentals can be remember when you design Phytorid kind of system. Rest, the detailed design, I'll definitely share with you.
Okay, so the last question is, are these macrophytes plants perform good in all the climatic
Yes,
conditions or not?
yes. I already mentioned this point. Hydrophyte plants as well as bioculture. We have tested these two things at the temperature range from -5 degrees Celsius till 50 degrees Celsius. They work very well. We have actual plant installed with these temperature ranges, and they are working well from last many years. We are meeting the standards.
Okay, Senefia is asking the alver plant.
Correct. I was about to, this question should come. Yes, Xenophia, very good question. For 20 mLT plant, all the design criteria are decided based on the BOD. Here, the BOD is less than 80 or somewhere 70. Plus, we have maintained the length of the plant is around 120 meters. But while going to so much of big length, we have also maintained the width. The width of the plant is around 72 meters. So we have maintained the ratio of length to width. And, by maintaining length to width ratio, we can easily construct the higher length. What I was telling for 25 meter length was the smaller capacity plant, less than 1 mLT or less than 500 KLT, because these plants are of more requirement. For 20 mLT plant, the overall design is different. Several parameters or several empirical equations are being used while designing that 20 mLT plant. So we have worked with the length, width, and depth ratio to follow the Darcy's equation and to allow the flow pattern maintain the subsurface flow and should not come to the top of the gravel surface that we have maintained while using many empirical equations.
Okay, so thank you so much, Vivek ji, for like answering all the questions in very detail.
Just take a minute.
Yeah.
So, of course, you can conclude it further. So, for all the Ethiopian participants, let me tell you, we have an online training also going on, wherein all the Ethiopian participants and more, I think 10 or 12 Indian participants are a part of that. This training is a part of that, first of all, we have the basic online training, then that goes to the advanced training. So you are directly coming to the advanced training, but those who cannot come are a part of the online training. So those people are joining us today. And for all the Ethiopian friends who are joining us today, I am sure that this whole session has been very, very informative for all of you, because in Ethiopia, they are working on integrated wastewater management, wherein they are establishing the fecal sludge treatment plant. Also, they are working at the decentralized wastewater treatment plants at various scales. So I'm sure this whole session would have been very informative for them, especially we have, arranged the online session from Dr. Jangde, so that they can get a very good understanding about this technology, because these are the people who are working on ground. So I think
it would be highly appreciated with the respected Ethiopian participant if you can just drop a feedback that will help me to assess how much, what is the level of information has been transferred to you. If not to the mark, I'll try to make it happen in the next presentation.
Yeah.
So please drop a feedback for the presentation. That will help me to improve.
You people have already appreciated in the chat box.
Okay, I
Yeah.
did not go through.
So great, but we have a feedback mechanism, of course, so that we will share it with you. Apart from that, for all the Ethiopian friends, if you have any question, because it was such an interesting session, if you have any more question, you can always write down to either to CSE, or you can do one thing, you can include Dr. Vivek to that online training,
Definitely.
because they must be having some questions, so
Sure.
we can take it directly over
To
there.
answer those.
Yeah. And for our friends who are here, I know there are many questions, cropping in the mind. We can take up all those questions during our dinner session. He is there with us, and he can take all those questions. Rest, I will leave it to Jyoti and Paraz to conclude.
Yeah, again, thank you all the participants for hearing very patiently and having an interesting session, and wish you a very, very happy Diwali. Yeah. Thank you.
Okay. So, thank you so much, Vivek ji, for a detailed session. It was very enriching and very well explained. I hope कि participants को बहुत अच्छा लगा होगा जो like live sessions ले रहे and Ethiopian friends as well. So, as Sumita ji explains, we will include Vivek ji in our online training group. You can ask your questions. You can also share your feedback in that group. And we will also share with you this recording. We will share this recording with the advanced training participants as well as with online training participants. And this presentation will be shared with you as well. So thank you, Vivek ji, once again for detailed session.
So with this, we come to an end for day one. So we first short some feedback share कर रहा हूँ group में. तो आप लोग बस इसको fill कर दीजिए. I think group पे आगे आप कर दीजिए.